Welcome to today's lesson. Our topic for today is complex numbers. When you talk about complex number, you're talking about a combination of real number and an imaginary number. A complex number is written in this form. You have z equals to a plus ib. This a is the real part, and the ib is the imaginary part, where I is the root of minus 1. And we know that we cannot get the square root of a negative number. So I is the root of minus 1. In some places, you can see it as I squared is equal to minus 1. Now, if you talk about the real part, like I mentioned earlier, the real part of z is a, and then the imaginary part of z is I b. Now, in the following examples, I want you to differentiate between the real part and the imaginary parts. We have some numbers here. 1 plus 2i. So the real part is what? The real part is 1. And then the imaginary part is 2i. Then we have something else, 7 minus 9i. The real part here is 7. And then the imaginary part is minus 9i. Okay, so what do we have? Minus 8i. Here, the real part of z, we don't have anything here, so y 0. And then the imaginary part of z is minus 8i. So you can say this one is purely imaginary. It's a purely imaginary number. And then here we have 14. The real part is what? Here 14. And then the imaginary part of z is 0i. So you can say this one is a purely real number. Now on the Cartesian plane, we are to describe a complex number on the Cartesian plane. This x-axis is the real part, and then the y-axis is the imaginary part. Yes, so here we have 0, and then we have I, 2i, 3i. Then here we have 1, 2, 3, 4. Okay, so here we have 1 here, and then we have 3i. So we plot this, so we join this to this. So this is 1 plus 3i. Yes, is the real part plus the imaginary part. So this is the graphical description of this complex number 1 plus 3i. Now, if you want to write the absolute value of a complex number, so we have a complex number in this form, a plus ib, we can write x plus iy. If you are to give the absolute form of this is z, okay, we square both sides, is I y all squared. Yes, and then we have this z squared. Yes, we have x squared. Remember I said I squared is minus 1. Yes, so here we have I squared as minus 1. So this plus minus 1 of y squared. Yes, and this one is minus. So the absolute value of minus is going to give us plus. So we have y squared, and then we introduce square roots to both sides to cancel the square. So we have something like this. Yes. So now let's carry out some arithmetic operations on complex numbers. Yes, basic arithmetic operations. So the first one, we'll be dealing with addition of complex numbers. So we have a plus ib, this is the complex number, and you have to add it to another complex number. So the real part will add itself to the other real part, and then the imaginary part will come together. I is common to both of this. We have b plus d. Yes, so the real part here together. imaginary together because I is common, that's why I brought it out. So for example now, we are asked to add 2 plus 3i plus 5 plus I. You have something like this, you have 2 plus 5, this is the real part here, the real part here, and then we have I is common here, we have 3 plus 4, so here we have 7 plus 7I. Now if you want to subtract complex numbers, you have A plus ID minus C plus ID. So for the same thing, you pick this real part A minus the other real parts. Then you pick the imaginary I is also common here, B minus D. Are you following? So the subtraction is based on the common factors A minus C, the real part, then I is common here, you bring out I, B minus D. So if you have an example here, 3 plus 2I minus 2 plus 9I. You pick the real part first, 3 minus 2, then plus I into brackets 2 minus 9. Someone might be wondering that why do we have plus here? Because we're adding the real parts to the complex part, but the subtraction is based on the common factor. So real we subtract real, complex, sorry, the imaginary we subtract the imaginary. So then we have 3 minus 2, 1 plus 2 minus 9, this gives us minus 7i. So addition multiply subtraction has minus 1 minus 7i. So if you okay, so in case you're not able to get this, we can expand it so that you can see how we came about this. So let's expand this. A plus IB, yes, let's bring it down. A plus IB minus C plus ID. We're going to expand this now. So if you open the bracket, A plus IB, this one gives minus C, then subtraction multiplies addition gives you minus ID. So we have opened the bracket now. We bring the common terms together. It gives us A minus C plus IB minus ID. Now if you put them into brackets, we have A minus C into bracket plus I into bracket B minus D. So I hope you've been able to get this now. Then we have multiplication. So if you want to multiply complex numbers together, is C plus ID. So A multiplies C, this gives AC. A multiplies ID, it gives ADI. IB multiplies C plus BCI. And IB multiplies ID, this is I square, yes, I square BD. So we have AC, yes, plus ADI plus BCI. I square gives us minus 1, so minus 1 times plus gives us minus 1 again, then BD, another BD, which is minus BD. We take common terms together, that's AC minus BD plus ADI plus BCI, yes. We'll put them in brackets, put the common terms in brackets, so these are the real parts together. Then is the imaginary parts, AD plus BC. We are able to multiply this. So for example, we have to multiply these two complex numbers. I want you to pause this video now and try it out on your own. You can multiply these two complex numbers together. Okay, so now we are back. 5 times 2 gives us 10 plus 5 times 3i, that's 15i, plus 4i times 2, that's 8i, plus 4i times 3i, that's 12i squared. So 10 plus 15i plus 8i, I squared gives us minus 1. So minus 1 times plus 12 gives us minus 12. So we pick the common terms together, 10 minus 12 plus I into bracket 15 plus 8. So this gives us minus 2 plus 23I. So we've come to the end of the class. I want you to try out more examples on your own. I wish you luck. Bye.